So far we have looked at how to create and operate on vectors and matrices in Matlab. And now when I talk about matrices, I mean those kind of which we define in 2 dimensions, so how many rows and columns we have in the matrix. However, Matlab allows you to actually think in higher dimensions as well. So a classical matrix would be understood as 2-dimensional. So it has dimension n1, the rows, and n2, the columns. But you could as well, if you think of that matrix in kind of spatial way, you would have maybe a matrix which has 3 rows and 4 columns. But then on top of this matrix, you could stack up more similarly looking ones, or actually same looking in terms of size, but maybe having different content. So you could have multiple matrices or multiple layers which are equally sized and are kind of constructed into one 3-dimensional matrix, for instance. So Matlab does have this functionality, and actually you can go beyond 3 dimensions as well, but that may be a bit harder to imagine. Where would we use such higher dimensional matrices? Well, let me give you an example. It's very useful when you handle bigger data. For instance, 2-dimensional matrix, or let's start from 1 dimension. You may have maybe one stock price, and you have its price over time. So you have dates here, and you just have a time series which has values for that particular stock. Now think of it that for that stock, you could actually have not only the price, but you could have, so let's say this is the price, but you can also have maybe the daily opening price, you would have closing price, you would have maybe the day's trading minimal price, maximal price, and maybe the trading volume of the day. So you see, for one stock, we could easily make a 2-dimensional matrix already. So we would still have, in the different rows, we would have different dates, and then in different columns, we would have different properties of that stock or different information related to one stock. But now think that you could actually have multiple stocks. So now if you're handling data, for instance, in Excel, that would mean you would need multiple sheets, and you could either have in one sheet, maybe one sheet devoted to price, and then you'd have many columns with different stocks, and then another sheet for opening price, another one for closing, minimal, maximal, and so on. Or you could have such a matrix in one sheet for one stock, and then you would have multiple sheets for different stocks. In any case, it doesn't seem very practical. But in Matlab, you could actually have all this information arranged in one 3-dimensional matrix, because you would just now, for a particular stock, you would have this kind of 2-dimensional matrix, but then when you add 3rd dimension, then each next layer of our 3-dimensional matrix would have equivalent information for different stocks. So that's, I think, the most intuitive example I can give. And of course, you could have even more pieces of information, so then you would add them on to higher dimensions. So for instance, many functions in Matlab which have this feature of creating matrices. So what we have looked at already, like zeros and ones, or maybe random number generators, they do have the ability to actually create higher dimensions as well, not only 2 dimensions. So for instance, in here, this round 3, 4, 5, what it does is that it will create like a three-dimensional matrix or a box filled with numbers, where now in here we would have 3 rows kind of on the flat dimension, then 4 columns in this way, but then we would still have 5 layers this way. So that also works for instance, zeros and ones. And this round n, for instance, generates normally distributed random numbers from the standard normal distribution. So that's the one with mean 0 and standard deviation 1. Now let's have a look at the code, how things could be done. So if, for instance, you have to create such a matrix yourself and not by using already a function which does the 3 dimensions immediately. So I would like to create something like this. 2 matrices, which are 2-dimensional, are connected into one 3-dimensional matrix, and the 2 layers have numbers 1 from 1 to 8, the other one 11 to 18, and then they are arranged as 2 by 4. So I could have done it directly like this. So I would say that A is 1 to 4, 5 to 8, and then that B is 11 to 14, and then after semicolon 15 to 18. And this is perfectly fine. But I also wanted to show you one of the Matlab's built-in functions called reshape. So what I do here is that first I create a vector just with numbers from 1 to 8. So that means it will be a row vector arranged in this way, 1, 2, 3, 4, up to 8. And then what I do is that I want to reshape it to look like this. So I want size 2 by 4. And now the question is why I haven't just said reshape A to size 2, 4. Well, the reason is that when Matlab starts reshaping, so when we use this reshape, it looks what we tell it to make the shape, and then it fills the places by columns. So that means that if I just did reshape A to size 2, 4, what would happen? It would go this way, and it would take 1, 2, and fill them this way. So 1 and 2 will be here, then 3, 4, 5, 6, 7, and 8. So that's not exactly the matrix I want to see. So that's why I ask it to reshape it first to 4, 2. So then I know that my 1, 2, 3, 4 will go to first column, then 5, 6, 7, 8 goes to the second one, and then I transpose it. So then it means that it will, what was in the first column here will be put into first row, and then what is in the second column will go to the second row. Okay, so I do this with both A and B, and then here is the trick how we tell Matlab that C, so our resulting 3-dimensional matrix, should have those 2 layers. So now what happens is that I tell it that in the first 2 dimensions, so the classical row and column places, just fill up all of them. You see, I don't even have to declare how many there are. But then I say that into the 3rd dimension, put for me A, and then in the same way, since I know B is same shape as A, so I again say the first 2 dimensions of C, just fill up all of them, and then in the 3rd dimension, in the second layer of the 3rd dimension, then put matrix B. Let's jump to the code and see it's done. So once again, A is 1 to 8. And now I will show you what I mentioned about this reshape. So if I just say like this, reshape my A matrix into size 2 by 4, I would just get it like this: 1, 2, 3, 4, 5, 6. So this is not the arrangement I was looking for. That's why there was this change here, that we want 4, 2, and then we transpose it. So now this is the way I want it. First row is 1 to 4, second is 5 to 18. Then we do the same trick with B. So it was 11 to 18, and B is reshape B, 4, 2, and transpose. And also notice that my reshape result I put back into matrix A simply because I don't need this initial row vector anymore. So it's okay if you know you're maybe just making a row version of something, some initial, but then you are changing it for the purpose of your work in some way, and you don't really need this initial value, then you can overwrite or assign new value to it, and it's okay. But you always have to be aware of whether you can or you cannot do it in your code. Will you need this initial value later on or not? In my case, I don't need it, so that's why I just put my reshaped matrix back to A. So in this way, you can see here that A is actually now the reshaped one, and we don't have in the workspace anymore that initial vector. There is a semicolon here, so we know it's a matrix with 2 rows. All right, so once these two are done, then I do the assignment to C. So for the first one, I say it's supposed to be A, and then second one is B. So now Matlab doesn't have the ability to actually display for you that matrix in 3 dimensions, but it does inform you that indeed the first layer of a 3-dimensional matrix has this content, and the second layer of this matrix has this content. And similarly, you could fill up more layers if you wanted, and of course if there are many more, but what you're putting in maybe has some pattern, or it's all the same stuff, then you can use loops to do that. So then instead of having explicit indices here, you would just be having some index which is being changed by your loop. And this 3-dimensionality, of course, goes as far as you like, so there could be really many layers. I think the only limit is Matlab's working memory space. So it may run out of memory if you create way too big matrix, but that can happen even in 2 dimensions. You might not be able, for instance, to create a matrix which is 1,000,000 by 1,000,000. There is some limit in Matlab's capabilities, but otherwise the number of dimensions are relatively free to your own choice.